guys, in this video I'm going to show some of the frequently asked interview questions related to DHCP. So I'm going to use Cisco Packet Tracer tool to show how the DHCP process works. So before we start discussing about the interview questions, uh, everyone should be aware, how the DHCP basically works. When you don't want to statically configure IP address on a PC, you can simply select the DHCP and the PC will request for the IP address. And if you have a DHCP server configured in your local LAN, it will send the required IP details like a default gateway, the IP address and the mask, the DNS detail, everything for a PC to connect to the internet. It will update. These are some of the frequently asked questions, like how the PC gets the IP address from the DHCP server, basically how the DHCP process works in order to get the IP address, and what are the DHCP messages exchanged between the client requesting the IP address and the DHCP server. That is the DHCP discovery and the DHCP offer, DHCP request, and DHCP ACK, the acknowledgement from the DHCP server. And the another question, like what is the source and destination port number in a DHCP packet, and what is the source and destination IP address in a DHCP packet when these messages are passed, and also what is DHCP release and what is DHCP renew. These are some of the expected questions when a interviewer taking the interview. These are some of the expected questions that a candidate can expect related to a DHCP. Now let's start with the first question, how the IP address, assigned for a PC in a DHCP process, or simply we can say how the DHCP process works. So I'm going to start the simulation mode. Let's go to this PC1. So PC1 right now don't have any IP address. Let's check that IP config. So right now it doesn't have any IP address, it is 0. And let's go to the IP configuration. Right now by default it shows static. So I'm going to click on DHCP. The moment I click on DHCP, the PC will send a DHCP discovery message. Let's see that. So I have clicked the DHCP and it is requesting an IP address. You can see here. Let's close this, and you can see the packet which got generated. You can see from PC1 at device PC1 there is a DHCP packet. Let's open this and see. So this is a DHCP packet. This is a DHCP discovery packet. You can see here the DHCP client constructs a DHCP discovery packet and it sends out. And you can see here itself the source port is a UDP port 68 and the destination port UDP port 67. This is a packet that is coming from a client towards the server, and you can see the client doesn't have any IP address, so the source IP address is 000. The destination IP is 255.255.255. So it's a broadcast packet. You can even see in the Ethernet header the source MAC is the client MAC address, and the destination MAC is FFF, which is a broadcast. This is the header information. Ethernet header source will be the PC0. I think this is PC1. Yeah, this is PC1 MAC address. And destination MAC is FFF. That is the Ethernet header. And in the IP header, source IP will be 0, destination IP will be 255.255.255. And under the UDP header, the source port will be 68 and the destination port will be 67. And this is the DHCP header, and right now the client doesn't have any information. Only the client hardware address information is entered in this particular packet. This is the discovery packet. And you can see here, this is actually a simulated version of a packet capture. The transaction ID is 0. Ideally, there will be a transaction ID here. The entire what we call as a DORA process, that is DHCP discovery, DHCP offer, DHCP request, and ACK will have the same transaction ID actually. Okay, now let's click next. So it's a broadcast packet. It goes to the switch. So the DHCP discovery packet went to the switch, and the switch sent that to all the devices connected in the switch, like to the router, to the PC2, and it also sent to the DHCP server. So here the DHCP server is like 192.168 1.200. It receives the packet. Let's open this and see. Yeah. So the packet came from the PC1. You can see the MAC address 3CC6 and destination is FFF. So you can see here now the DHCP server, the moment it receives that discovery, so this packet I just opened up, the one in the the colored one, and you can see here the source is the DHCP server 192.168.1.200, and it's sending a ICMP packet. It generates this packet for 192.168.1.12. So basically, it is trying to assign this IP to the client, and trying to check, any other device in the network have this IP, assigned, just to make sure there is no any duplicate entries. So it sends the packet. So the server 192.168.1.200 is sending a ARP request for 1.12, and ideally it should not get any reply because this IP is not configured anywhere. Let's see. So it doesn't got any. So now once it knows the IP is free, it is sending a DHCP offer message. This is actually an offer message. Let me make it big. So this is the DHCP offer message coming from the source IP 192.168.1.200. That is our DHCP server IP address, and you have to note down the destination IP address 255.255.255. So the packets coming from client to server, and packets coming from DHCP server towards the client always carries the destination IP address FFF. So it's going to be a broadcast IP. And even on the Ethernet header, so this is the Ethernet header, you can see the destination address is always FFF. So it's a broadcast packet. And also you have to note down the UDP header. So now this packet is DHCP offer packet coming from a server towards the client, and that's why the source port is 67, destination port is 68, which is for client. And here these informations again, this is a simulated packet capture, so transaction ID is not there. Otherwise it will show the same ID here. You can see your client address. So it is actually offering this IP address 192.168.1.12 and coming from the server address, and the client hardware address, this particular one, so that this client alone accepts this IP address actually. And you can see even the domain name is coming, whatever the DNS we given in the DHCP server. Now let's see the packet. Again, it's a broadcast package. You can see it goes to all the devices. So PC1 eventually receives it, and you can see the router 1 and PC2 rejects that packets. Only PC1 accepts it because in the DHCP packet, the client hardware address is mentioned here. So the PC1 hardware matches with that, so it accepts it actually. So it's not rejecting it, and now it is sending a request packet. This is the DHCP request packet from PC1 towards the DHCP server. You can see again here, let me make it bigger. So it's coming from the PC. You can see under the Ethernet header, the source MAC is PC MAC and destination is FFF. Again, it's a broadcast packet. And it is actually a DHCP request packet, telling the server that it is ready to accept it. So the server receives it, and now the server is sending the acknowledgement packet. Let me open this. So again, even the acknowledgement packet, you can see the source and destination MAC. The destination MAC and the destination IP always remains a broadcast, and source port and destination port changes accordingly. And this packet is client hardware address given here, and it's coming from a DHCP server, and the client IP address is this. And you can see the relay agent is 00 because here there is no relay agent. Our DHCP server is located in the same LAN. So now the PC receives it. I can see the PC receives it. The acknowledgement packet from the DHCP server. And here actually what happens, the PC now knows it can assign this IP. And what we have seen so far is actually called the DORA process. Just to remember, like discovery, offer, request, and ACK. So the PC sends, whenever you enable DHCP, it sends DHCP discovery to the server, and server sends a DHCP offer back to the PC, and the PC again sends a request accepting that particular IP address, and again DHCP server sends a acknowledgement for that. Once that acknowledgement comes, you can see the tick mark, the PC gets the IP address. So this complete process is DORA process, and the points to remember is the PC, the client, the DHCP client source port will be UDP port 68, and the packet, when it goes from PC to server, the server destination port will be UDP port 67, and when the PC sends the communication towards the server, it uses the until it gets the IP address, it uses the IP address 000, and source MAC will be its own MAC address. And when the packet coming from the DHCP server towards the PC, it uses its own IP address because server already got the IP address 192.168.1.200, and destination IP address will be 255.255.255. That is a broadcast IP. Now you can see the IP it accepts once it gets the acknowledgement. So the moment the PC configure this IP, you can see a ARP packet is going out. Let's see this ARP packet, and you can see the frame is a gratuitous ARP request. So in my previous videos, I have shown you how the IP duplication is identified in any LAN network. Whenever you configure IP address on a PC interface or any layer 3 interface, whether statically or using DHCP dynamically, when the IP is configured, it sends out a gratuitous ARP request, and I'll show you the gratuitous ARP request. You can see the source IP and destination IP with using the same IP, because this is not a normal ARP request to resolve a MAC for IP address. This is a gratuitous ARP request in order to find any duplication of the same IP exists in your LAN network. So the moment it's going to configure this IP 192.168.1.12, it sends a gratuitous ARP request, which is a broadcast packet. It will be sent out in the switch. Let's see that. It should not get any reply for this ARP request. In that way, it knows there is no duplication in the network. In case if it receives, it comes to know there is a duplication. So you can see it's a broadcast packet. So you can see all the devices in the LAN actually rejecting that packet. So now the PC would have got the IP address. Let's see that. You open the PC. You can see now DHCP request successful, and it got the IP address 192.168.1.12, the subnet mask, the default gateway, and then the DNS server IP address. Let's go to desktop and then the command prompt. This is the PC1 command prompt. Earlier there was no IPs configured. Now you can see the IP address configured 192.168.1.12, the default gateway, the subnet mask. I give /all, we'll get the DNS information and also the DHCP IP address details. So now let me log into the DHCP server. So DHCP server under services, under DHCP you can see, so this is the server pool. Whatever information we are feeding here, that is what you are going to get in your PC, the DHCP client. So we are giving the default gateway 1.1, DNS 888, starting IP 192.168.1.10, and the subnet mask /24, and the maximum uses 100. So from 10, starting from 10 in that particular subnet, you will get 100 IPs. So now when I go to this PC CLI, let me go to the desktop and then go to IP config, and whenever I click static, the IP goes. Whenever I click DHCP, it is requesting the IP. And let me come out of the simulation mode. I'll go to the real time so that we can see how it getting. So you can see now it got the IP 12. So again it got 12. So whenever I click static and DHCP, you can see it keeps getting the IP in that subnet itself. Okay, let me go to PC2. PC2 doesn't have any IP address. Go to desktop, in the command prompt you can see IP config, nothing is there, and let's go to IP configuration. Let's click on DHCP. Okay, it got the IP 13. So 12 was already assigned to PC1, and now it got 13, and the rest of the other things like the subnet mask, default gateway, and DNS will be the same. So now coming back to see the questions that we have seen earlier, like how the PC gets the IP address from the DHCP server. We have to explain the DORA process, that is DHCP discovery, DHCP offer, DHCP request, and DHCP acknowledgement process. We call it as a DORA process, just to remember the flow. And what are the DHCP messages exchanged between the client and DHCP server? These are the messages like DHCP discovery, offer, request, and act. And what is the source and destination port, and what is the source and destination IP in a DHCP packet? We can say the client uses the client port will be like DHCP client port will be like 68, and the DHCP server UDP port will be 67. Like for example, when the client is sending a DHCP packet, the UDP port will be like source port as 68 and destination port as 67 for server. When the server is sending the request, again it will be like destined towards 68, and source will be 67. The only thing changes here is that the source IP, when a client is sending the request, like when the client is sending the DHCP discovery, the source IP will be 000, the destination IP will be 255.255, which is a broadcast IP. And when the server is sending a reply, the server own IP address, the DHCP server own IP address will be the source IP address, and the destination IP remains the same throughout the DHCP process. Towards the DORA process, the destination IP remains same, which will be 255.255.255.255. Now let's see this last question, like what is DHCP release and renew. So these are other DHCP message type which we'll see now. So now I'm in the simulation mode. Let me open the PC1. So in the PC1, if I want to release this IP, if I don't want this IP and I want to release this, basically when you You can release this with command like ipconfig / release. You can see it is releasing that. So this is the DHCP release packet. DHCP client constructs a release packet and sends it out. Now we'll see it goes to the DHCP server, and you can see this packet also a broadcast packet. It is going to all the devices and it goes to the DHCP server also. So now the server will keep this information and then release that IP, so that any other device comes in the network and ask for IP, it can use that IP actually. Now let me go back to the PC. Now this PC doesn't have the IP address. Now if this PC wants the IP address again, it can do the renew actually. So you can see the PC1 is sending DHCP client constructs a discovery packet and sends it out. So it's trying to get an IP address. This is the DHCP renew actually. So you can see the packet goes to the switch, it goes to all the devices. DHCP server also receives it. So now you can see DHCP sending ARP request for the IP 1.12. So it's trying to assign the same IP to this PC1 and to check whether 1.12 is not used anywhere else in the network. It is sending a ARP request. You can see it's ARP packet. So it confirms, there is no other PC. So now it is sending the DHCP acknowledgement packet. So that was a DHCP offer, and it sends a request. Now the PC gets the IP address, and it went through the DORA process actually. You can see your client address 1.12 it got, and immediately it's sending a ARP request for, it's a gracious ARP request for 1.12 just to make sure there is no duplication. And now let's see the PC1. Okay, so the moment I give ipconfig / renew, it renews and it gets this IP 1.12 and all the other details. So that's about what is DHCP release and renew. So when the DHCP client don't want to use that IP anymore, it will send a DHCP release message. The server receives it and notes down that this particular IP is free to assign to some other clients. And the DHCP renew is like to renew the IP address. It goes through the complete DORA process and then gets that IP. Now let's see some real-time DHCP packet captures. Because in the packet tracer we saw only the simulated packet captures. So this is the typical DHCP messages you can see in the Wireshark. DHCP discovery, DHCP offer, DHCP request, DHCP ACK. Let me open up this DHCP discovery packet. So you can see the Ethernet header source will be the PC, the client which is requesting, and destination will be the FFF. And then the internet, you can see the IP header basically. The source IP and destination IP. Source IP is 000 and destination is like 255.255.255. And let's see the UDP header. UDP header, you have source port 68, destination port 67. And you can see this is the DHCP packet discovery, right? And you can see there is a transaction ID. So this transaction ID remains same in the entire DORA process. And you can see here there is no IP address, like it will be, visible when the server is sending the IP. Let's see the packet the server is sending. So you can see um, this is the DHCP discovery. Discovery have source 0 and destination as FFF, and DHCP offer, which is coming from the server towards the client. The server source IP you can see, but the destination remains same. It's a broadcast, and it is trying to assign the IP 192.168.0.3, and the client MAC address is there, and all the other informations also here, like the router information, the default gateway, basically the domain name server, the domain name details. And here what I want to show is the transaction ID. Yeah, you can see the transaction ID is like 155C, and here also 155C. The DHCP request also, you can see the same transaction ID, and this is request is nothing but the client, DHCP client, the PC sending towards the DHCP server, accepting these all whatever information this DHCP server has given, like requested IP address. You can see this is the IP address the client is requesting for from this DHCP server. Once the ACK also, you can see your client address is 192.168.0.3. The server is saying that you can start using this IP address, that is comes under your client IP address. And again, the transaction ID is same, 155C. So you can go to this cloudshock.org/captures. Any protocol you want to study, you can use this CloudShock, where you can go through all the packet captures. So these are some of the topics I want to discuss related to DHCP. So once you understand the complete DORA process, and the interviewer may ask the particular packet, like DHCP request packet, what will be the source IP, destination IP, what will be the source port and destination port number. You should be in a position to able to answer that, and you should be in a position to first of all answer the complete DORA process, and also other message type, like what is DHCP release, what is DHCP renew, all those informations. Thanks for watching the video. Don't forget to subscribe to my channel and also hit the bell button. In the next video, I will show what happens when the server is connected to router on a different interface. That will be on a different network, and how the PC can get IP address using a relay agent.